To really understand the environment, we really have to understand humans, because humans have played such an integral part of what our environment looks like. Now, there's some areas of the world that humans haven't interacted with the environment and have left it fairly pristine, but unfortunately, a lot of areas have been used by humans, have been obliterated by humans, but have also been built back up by humans. So it's incredibly important to understand how our population has changed and that link to the environment. So here is a graph that was created of human population growth, similar to the one that you created. And it kind of shows where humans have been, at least population-wise, for quite a long time. Now, humans have been on Earth as the species Homo sapiens for about 200,000 years. This graph only goes to the year 0. So there's actually a whole long line of humans from 200,000 years ago. But just like they were here in the year 0, a very, very small population. Very steady growth, but very small growth. But as you can see, really at the turn of the 1800s, that's when we start hitting the billions. And it wasn't a gradual increase. I mean, once we hit 1 billion, we hit 2 and 3 and 4. And you saw that doubling of the population was getting shorter and shorter, or not necessarily doubling, but adding another billion people. A billion people, like that is a significant amount of people. You can look at the year you were born, and more than likely we've added over 1 billion people just in your lifetime. Well, for some people, this is kind of scary, because looking at this graph, you see how big it's growing and how quickly it's growing. As of this year, actually as of this month, we had 7.5 billion people on Earth. 7.5 billion people, whereas in 1800, we hadn't even hit 1 billion yet. And again, this has been a cause of concern just because of how quickly Earth is growing, or how our population is growing, because the more people we have, the more resources we need, the more electricity we need, the more automobiles, the more electronics, the more stuff humans need or humans want. Now, something interesting about this graph, I had this arrow just pop up. It shows a huge dip in the population. Now, to you, looking at this doesn't actually seem that large of a dip, particularly when looking at today's human growth, but this is actually really significant. It was nearly 1/3 of the population died around 1400. So some of you may know what happened at this time period. This was the Black Death, or the plague. It killed about 1/3 of the entire world population. But why? I mean, we had this whole scare of the plague not too long ago. Like, why didn't it kill so many people? Well, back then we didn't really understand medicine. We didn't really understand how disease is transmitted from person to person. And so it made a huge dent in our human population. And I'll talk about why that's important here soon. Now, looking at this graph, you may also think, like, where does it stop? Where can it stop? Can Earth support all of these humans? And the answer is yes. Now, some of you may think, well, I mean, we have world hunger. We have people who are starving. Obviously, we don't have enough resources. Unfortunately, or fortunately, depending on the way you see it, we have plenty of resources. That's not the problem. The problem is the distribution of those resources. If you look in the United States, we're gluttonous. We have lots and lots of food. We waste lots and lots of food that can go to other people. So the problem isn't the lack of resources, but more of the lack of wealth, or the distribution of wealth. So scientists and different organizations have looked at this question, how many humans can Earth support? And our current estimate is around 10 billion, which we're not at yet. We have a while before we hit that number. But it's kind of interesting to note that, Earth can support this, but Earth couldn't always support that many humans. If we look back at the 1400s, when, the Black Death, killed a bunch of people, at the time, Earth could not support 7 billion people. It just couldn't happen. That carrying capacity was really low. Carrying capacity means the number of organisms an ecosystem can support indefinitely, which means if I can support 1 billion humans now, I can also support 1 billion humans in 100 years. The resources they use will be replenished in time. Now, in 1400, Earth couldn't support 7 billion people because we didn't have the knowledge and the resources to support that many people. But that's changing. Here in the year 2017, we can support that many people. So there's a couple of reasons why. One, there are more areas on Earth to live. We can live in new habitats now. Not new as in, oh, there's a new place on Earth. More of places we knew about, but we couldn't live there. We have a colony of humans in Antarctica. In 1400, we didn't have the technology to support people there. In the year 0, we didn't have enough technology to support people there. People live in deserts. Las Vegas is like a great example of technology. Las Vegas gets all of their water from California. Well, we didn't have the technology to distribute water like that hundreds and hundreds, thousands of years ago. So we can live in new places, meaning we have more space for our population to grow. Related to this is we have better farming techniques. This is probably one of the most important reasons why the human population can keep growing and we have enough resources. Not only do we know how to plant crops, so we're not hunter-gatherers anymore, but we know how to make the most of the farmland we have. We have irrigation, so if we're going through a drought, we can bring in water. We know how to use fertilizers. We know how to combat pests. In some of our crops, we use genetically modified organisms, so we actually alter the DNA in order to better suit them. So we now make a lot more food per acre of land than we ever have in the past, meaning we have more food. More food means the number of humans that can be supported on Earth increases. Now again, the problem isn't a lack of food, but more the lack of wealth. But looking at a resource perspective, we've got tons of resources. And another reason that our carrying capacity is increasing, why during the Black Plague days we couldn't support 7 billion people, is because we understand disease. We understand viruses and bacteria. We're still learning a lot, but we know it a lot better than back then. If someone's violently ill, we know not really to touch them and don't kiss them and don't play with their blood. We know that stuff now. Didn't quite know that back then. So that's why we don't have huge outbreaks of disease, is because we understand how disease spreads. This is incredibly important. So more humans can be supported on Earth. So although this graph looks scary, and there are problems associated with this type of growth, it's not the end of the world. We can support all of these humans. However, there might be sacrifices to the environment because of that. And that's kind of what we explore in this course. Another way to look at human growth is to look at fertility rate, a metric called the total fertility rate, or you'll hear me say TFR for short. It's a way to look at how reproductive we're being, and it's a good measure of how fast the population is growing around the world as a global metric, but also as a country metric to see which populations are growing the most. So our TFR is just how many children is a woman having. That's it. It's a good metric of how fast your population is growing. Now, as I mentioned before, this can be different around the world, and that's what this image is showing us. So in countries that have low TFRs, so say 1 to 2 children, most of them are our developed countries. So we've got the United States, Canada, most of Europe, even China. We'll talk about China in a little bit. Australia. But areas that are having a lot of offspring are mainly those in Africa. And there's different issues surrounding that. Although Africa is having many, many children, their population actually isn't that large. You've probably learned for quite a long time that China and India are the biggest populations in the world, but they're actually not having that many kids. The reason Africa doesn't have more kids, or I should say a higher population, is because of a lot of the poverty surrounding a lot of the nations here. They have a lot of children mainly because most of the children don't survive. This is due to a lack of healthcare, a lack of food, a lack of nutrition. And so there's a lot of different childhood diseases and even adult conditions that kind of keep their populations lower despite having this high TFR. Now, on a global scale, now thinking again back to that human population growth where it's growing incredibly fast, we can look at the TFR on a global scale, and it actually paints a really good picture for us. So here, if we look at 1950, this is again the world TFR. 1950, so about 60, 70 years ago, our TFR was 4.9, an average of 5 children per woman. It's insane. You look in the entire world, no wonder our population was growing so fast. But if you look to today, or really 2016, it is half of that rate. We are having half as many kids as we were 60 years ago. Only about 2.4 children per woman. And this is great news. And the reason this is great news is it means our population growth is slowing down. Although that graph was like a really sharp increase, it's slowing down. So although it's going to keep increasing, we're still having kids, it's not increasing as fast, which means, yeah, it's actually likely we could kind of even out around 10 billion people. And that's okay. It's okay to level out to that because that's kind of our estimated carrying capacity. So this is good. Population is growing, but the growth rate is slowing down. Now you may wonder, what if I wanted to stop? What if I wanted the population to be at 7.5 billion people? I don't want it to go up, but I also don't want it to go down either. What TFR would you need? Now you may think 0, but that wouldn't be right. You're like, oh, well, 0 population growth, I want a TFR of 0. No, 0 would mean no one's having kids. So the population won't be growing, but it would be declining because people would be dying, and so your population would actually be decreasing. So what you actually need is 2.1. So I'll explain the 2 first. You have a mom and a dad, and they'll die. I know, I'm sorry. They'll die. Well, when they die, you need something to take their place, such as 2 children. You have 2 kids, and at least population-wise, they replace you. And then they have 2 kids that will replace them. Now, some people are born with different genetic conditions that make it so they can't produce offspring. Or they have 2 children, but one dies before they can reproduce. So that 0.1 in the 2.1 means that, yeah, some people in the world need to have 3 children because not every person can have a child, or not every child survives. So this is a really key number, this 2.1. If we wanted to have 0 population growth, but also we don't want to decline either, we want to stay right where we're at, we need a TFR of 2.1. Now you may think, well, 2.1, like, okay, why does that matter? Well, I just want to show you a quick comparison. If we were to start right now at having a TFR of 2.1, that means we'll have around 11 billion people in like 130 years. Okay. If we were at 2.6, so only a 0.5 difference, that's 27 billion people in the same time frame. So over double that. So although these seem insignificant, still incredibly important, and why it's a really good metric that researchers look at. And again, this really helps us understand human populations, which means we can better understand how we will affect the environment.